All right, guys, almost done with alkynes. Hang in there, okay? This one we've actually looked at before. This is deprotonation of a terminal alkyne because this hydrogen gives this alkyne a pKa of about, do you remember the value? It's about 25, okay? And remember, ammonia is about 35. And so if I can make something weak, then that drives the reaction forward, okay? So I'm going to take the opposite then, amide as my base and alkyne as my acid. So when I do this reaction, I deprotonate the terminal alkyne and I get this alkynide ion. Okay, so once I have that alkynide ion, I can use it for something, use it for good, okay? Which is, for organic chemists, the best thing we can do is to make carbon-carbon bonds like Legos, build larger and larger molecules. So this is our first carbon-carbon bond forming reaction, basically like an SN2 reaction. So you've already done that before. So I have a nucleophile here, alkynide ion, it's a good base. I'm going to attack the carbon group of an alkyl halide. So this dipole makes this R group welcoming for a nucleophile. So this is my electrophilic carbon. So this reaction is pretty much like an SN2 reaction. So that means this is going to be great for primary and methyl halides, but not so much for tertiary because too much steric hindrance. Going to really hinder the reaction, slow it down if it's too bulky where I'm attacking. So the reaction is going to simply be, all right, so I just added a new R group, so this is a new carbon-carbon bond right here. Notice the triple bond was not touched, it just hangs around for the ride, which is great because then I can use it to do more reactions. So this is often a good first step for a lot of multi-step reactions, is adding a chain and then using that triple bond to add more exotic things to this group. So to do this reaction, it's called alkylation. We're adding an alkyl group. To do that, we need step 1, a strong base. Again, a sodium amide is really great at converting these alkynes into alkynide ion. And then step 2 is going to be to grow that chain by attacking an alkyl halide, preferably a methyl or primary alkyl halide. For less steric hindrance, will be a faster reaction. And remember, SN2 is backside attack, so right here, and then let the leaving group leave. Now here, be careful, count your carbons. I got this carbon on the end, and I want to add 2 carbons to it. So here's my carbon on the end, 1, 2, okay? And there's no cis or trans to worry about with alkynes, right? Because they're linear, so there's no cis or trans. Okay, so let's see if you guys can work backwards, identify the reagents that you can use to make ethyne, or also called acetylene. This is what they use in welding, those acetylene torches where you put that little guard over your face, and it's very bright light that will damage your eyesight actually if you look at it. And here's acetylene, but I'm going to leave it up to you to draw out 7-methyl-3-octyne, and then go ahead and show me how to apply this alkylation reaction to do this transformation here. Okay guys, so here's my 7-methyl-3-octyne, and notice that the ethylene starting material, okay, is right here, is basically right here. Okay, so I need to add a group onto one side, and I need to add another group onto the other side. Luckily, these are both primary R groups. So what I'm thinking first is let's knock the easier one out of the way, which is the ethyl group. Okay, so I'm going to think about adding these 2 carbons on. I'm doing a squiggle line because I'm doing something called retrosynthesis, where I'm thinking about what are the pieces that I need to glue together. So I need this piece here, and I need this piece here, and I need to glue them together. So first, I need to make the glue. The glue is going to be from deprotonation. I'm going to have step 1, NaNH2. That's going to remove one of these hydrogens and make my negative charge here on this carbon, like that. Then the R group I need to add is not this, well, it could be this one. This is ethyl. It's perfect. Let's use that one. I'm going to use ethyl, and then a good leaving group like iodine or bromine is fine. And then all I have to do is then add on this other group over here. So to add on that group, I need to do another NaNH2 And then I want to add, and I want to do one equivalent. So I only want one of these to react at a time. So I might want to specify one equivalent each time. Otherwise, you could technically have both of them reacting. And then after that, I'm going to need this group 1, 2, 3, 4, 5. Okay, and then that's going to add both of those groups on there. So for practice, do more problems like that, but then also go back to your reaction tree and add alkylation reaction. Okay, alkylation reaction is step 1, NaNH2, step 2, RX. And remember to use a primary or methyl, secondary if you have to, but definitely don't use tertiary. The other thing I want you to add to your tree is your double elimination reactions. So wherever you've made halogens, definitely know how to go back using your NaNH2 excess. And that brings us to our last section, which is 9.11. When you learn all those reactions we just covered really well, you should be able to start linking them together. So, for example, let's look at this synthesis right here. We have an alkene going inside. So we have more carbons. We have 1, 2, 3 carbons, and here we only had 1, 2 carbons. So you're going to have to combine reactions because I only showed you one reaction where you could add carbon. That was the alkylation reaction, right? But that left you with an alkyne. What happened to the alkyne? Well, we went from an alkyne to an alkene. So there was a reaction where you learned how to do that. So it's a little complicated. So I definitely know just looking from this that I have an extra carbon that I added, but it had to be added with an alkyne. So I want to make this into an alkyne. So those are some hints for you. Okay, so turn this into an alkyne and then use some of these chapter 9 reactions. If you don't know what I'm talking about, make your reaction tree and follow it along. Okay, so how can I make an alkyne? Okay, look at your reaction tree. There's only one reaction where you can make an alkyne. So try to figure it out, and we'll go through it in a few minutes. Okay, guys, so just a little hint if you are stuck. The way that you can make an alkyne is think about putting BRs on there and then do a double elimination. Okay, so I gave you some of these ideas. Go ahead and fill in what reagents you would need to get there. And then pause it again and see, once you have that, can you figure out from here how to get to here? And the hint is you need to do an alkylation reaction, the one we just did in the previous section. All right, guys, so the reagents I need are Br2, and then I need excess NaNH2. And that's going to give me this negative ion. If I want to, I can use water and neutralize it, but I actually need this ion to add a carbon group. So I'm just going to keep water out of it for now. I'm going to add my alkyl halide, and that's going to get my methyl group on the end. Now the very last step is I need an alkene from an alkyne. That's called reduction. Remember, there's hydrogenation or there's the sodium in liquid ammonia. How do I know which reaction to use? Do I need Lindlar's catalyst? Do I need platinum or palladium? How do I know which one I need? Well, if you look carefully, this is a transalkene. So for transalkene, there's a very specific reduction reagent you need. Can you think of what that is? That's sodium in liquid ammonia. Okay, so that's what you'll need to reduce that to a transalkene. All right, so this is a 4-step multi-step synthesis problem. If you got it or you sort of have the idea, that's great, but I think a lot of students struggle with this because you really need to fill in these missing links, right? So what I recommend that you do is really learn one step at a time. Okay, learn one-step reactions really well, because there's no way you're going to link the different ones unless you know each piece really well. Then you learn the ways to put those words together, right? Just like speaking a language. So you got to have those first steps well. I also find it helpful to forget the reagents. The reagents, there's so many, it's mind-blowing. So what I do is I just draw the structures first. I know that this has to look like this, then it has to look like that. And then I think of what reagents I need to do that. So sometimes it helps to simplify it down so you only think of one thing at a time instead of multiple things at the same time. Otherwise, just keep going back to your reaction tree and think about how the reactions link together. And then I think you will get a better ability of seeing that. There's nothing better than practice, though. Even if you have a hard time, just try practicing and you'll start to absorb the different methods that are used. So you'll often see like alkenes going from cis to trans, or alkyne going to an aldehyde. You know, these are long chain going to a shorter chain, oxidative cleavage, shorter chain going to a longer chain, alkylation. Halogens, multiple halogens, just a couple versus 4. So that's, you know, these are patterns you'll see that will point you to certain reactions. So do as many practice problems as you can, including things like this one here, 9.29, and then also just having your map in front of you and really using it to learn and then weaning yourself off of it. Okay, so these are the ways that I learned how to do these. All right, so I'm going to sort of maybe go through 1 or 2 examples here, and then I'll let you get to it yourself. The first one is I would just count how many carbons I have. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. See, I already know then I'm adding carbons, so I have to do something here. And you know, so the first thing I do is I count carbons. Second thing I do is I look at the center of reactivity. And those centers are indicated by functional groups, okay? And I look for the relationship between those functional groups. Like, for example, this pi bond, I'm sure it is related to this pi bond here. And in order to add 2 more carbons, I probably had to have some kind of a triple bond here. And then I maybe reduced it to a double bond. So my first step is probably going to be going from this to halogens here. And then I'm going to make that into a triple bond with double elimination. And then I'm going to add some carbons on here. I need to add 2 carbons on here. And then once I have that, I'm going to make it into a cis alkene. All right, so that I just pretty much is the same problem we just did, isn't it? Okay, so that one's not too bad. Let's look at some strategies for this next one, part B. Same thing, let's count carbons. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so no alkylation on this one, but let's highlight this group is probably related to these 2 carbons. All right, so what I need to do is I need to add an OH group here, but it's not an alcohol. I need to have an enol, okay, because the enol is going to tautomerize. So now I need to figure out a way to add an OH group to a triple bond. So first I need to make this into a triple bond. So you'll see a common pattern here. To make a triple bond, we do this kind of a thing, right? From here to here, we make our triple bond. So we'll do the same thing for this one, make this a triple bond. Then we want to add an OH group on the terminal end, so that's an anti-Markovnikov. So I think for this one, I'm going to need the isoamylborane reaction. Okay, so BH3 or BH, 2R groups on the B, and then do your oxidation and hydrogen peroxide. All right, so just following those simple steps, I think you should be able to see how to grab these reactions, pull those reactions out and use them. And it just takes a little bit of practice. Okay, it takes a lot of practice. Good luck, you guys.